All right, here's three questions, applied questions of exponent log kind of question. First says radioactive element carbon-14 has half-life of 5750 years. Just saying that, um, from that information I can get the K value without even looking at anything else. They do talk a little bit about something losing 70.9% of their carbon, but losing a certain amount, that's not telling you the percent decay that's happening. And that's what we need to figure out first before we go any further, is to figure out what the K value is. And I can get that from that first information. So here's my formula. Amount at the end is equal to the amount you start with, E to the KT. And they say half-life. What half-life means is if I start, say, with 10 grams of carbon-14, in 5,750 years, it'll be half that amount, or 5. And so those are the numbers that I put in for my P0 PT. So I start, and I just came up with any number, but it doesn't matter what number you came up with. Like you could start with 2. If you start with 2, then that's going to go down to half of that, which would be 1, and it'll do that in 5750 years. Okay, so now I have to solve for K. First thing, divide both sides by 2. So I get a half is equal to E to the K times 5750. And then change it to log form. So it'd be log base E of a half is equal to K times 5750. And then divide both sides by 5750. Now, since this is a decay, hopefully my K value is going to be negative. Let me do this on my calculator. Log base E is the same thing as ln, so ln of 0.5 bracket divided by 5750 equals, okay, so it's negative 0.0001205. So that's my K value. So when that carbon decays, that's sort of the percent or the ratio that that thing is decaying by. Now, I can use that same information then, or not that same information, but I can use that K value in helping figure out how old the bones were at the time they were discovered. So now I'm going to be looking for T. I know what K is. And this one, they say they lost 70.9% of their carbon-14. So that means they started at 100%. And if they lost 70.9, what's 100 minus 70.9? That'd be 30, so 29.1. So 29.1, that would be the percent that they wound up at. So this is how much they lost. And so they're winding up at 29.1. So that's what I'm going to put over here. Is equal to 100 e to the k negative 0.0001205 times t. And then to solve, do the same thing. Divide both sides by 100. So I'll get 0.291 is equal to e to the negative 0.001205 t. Change to log form. Log base e of 0.291 is equal to negative 0.001205 t. Divide both sides by negative 0.001205. Negative 0.001205. So t is equal to the ln of 0.291. So ln of 0.291 divided by negative 0.0001205 equals. So time 10,244.2. So that's how old the whatever it is, mastodon is. Let's try another one. Data table shows this. Then they say use the data for 1960 to 2012. So again, my formula, this, e to the kt, and I can use that because it's doing an exponential decay. All right, so This would be where they'd start at. So in 1960 it was 77.5. So that's what I'm putting in for the starting number. And this is where it's going to end. So after that many years, how many years is that? 40, 52 years? So after 52 years, it went down to 42.9 is equal to e to the k. It looks like that's what I'm looking for. Times the time is 52 years. To solve this, same as we've done twice already, divide both sides by 77.5. So e to the k times 52 is equal to 42.9 divide 77.5, 0.5535, etc. 48, and then change it to log form. Log base of e of 0.5535 is equal to k times 52. So ln of 0.5535 divided by 52 equals, so my k value comes out to negative 0.011373, etc. So that's the k value. Oh, and that number would go right there. So the function then would be m of t equals, I'm just plugging stuff in for this right here. So the first number would be 77.5, that's what I'm starting at, times e to the, my k value, negative 0.011373. Then they say estimate the percent of adults who were married in 2015. So 2015, if I go 2015 minus 1960, I know that's 55 years. So then I'm going to use the same formula and figure out what the value of the function is if the time is 55 years. So it's equal to what I start with, 77.5 e to the k, negative 0.011373 times 52. Okay, and just plug that in my calculator. Make sure you put that top thing in brackets. You could just use a multiplication symbol there. It just makes sure both of those are in the exponent of the e. And then 2018, you do the same thing. For letter C might be a little bit more interesting question. They want to know what year the percent will be 35. So I'll use the same formula, but this 35 I'm going to plug in right there. So I'd have 35 is equal to 77.5. So this is where it starts, this is where it ends. E to the negative 0.011373 times t. And then I'm going to have to solve for t. One last one. And this question is similar to the other two that we've done. You have to first find a k value and then use the k value. So here's my formula. T0 is the temperature outside, and then or the surroundings, and then T1 is whatever the temperature is of the stuff that you're cooling. So if I use that formula, it says a jello salad starts at 45. So that's what my T1 is going to be. And then they put it in the room. That's going to be my surroundings. That'll be T0. Okay, so let's, oh, and then they say after 5 minutes, that would be a time, the temperature comes down to 54. So 54 is the end temperature. So let me plug stuff in that formula. Let me write it down again. Temperature after a certain amount of time is equal to the environment temperature plus what it starts at minus what the environment's at times E to the negative some cooling rate times time. So they're saying it ends at 45 equals the surrounding temperature is 68 plus it starts at, when it comes out of the fridge, at 45 minus 68 times E to the negative K, I don't know. But this all happens in 5 minutes. Okay, so now I'll solve this equation. I want to isolate this part so I can get at that K. but I'll first have to subtract 68 off both sides. So this would be negative 23 is equal to, I'll subtract this as well. Oh, did I put that number in right? Oh, this number over here is supposed to be 54. I might have said 54 and I wrote it wrong. Okay, so if I subtract that, that'll be negative 14. Okay, is equal to, I subtract that, negative 23, e to the negative k times 5, and then divide both sides by negative 23. So I get e to the negative k times 5 is equal to 14 divide 23. 0.609, call it 0.609, and then change it to log form. Log base e of 0.609 is equal to negative k times 5. And so let me do that. Whoops. So that'll be ln of my answer up there divided by negative 5. Okay, so the k value comes out to being 0.099287. So that's a k value. Then the question says, what is the temperature going to be after 10 minutes? So they want to know what T of 10 minutes is. So that's equal to the environment, 68 again, plus it comes out of the fridge at 45, minus the environment, all to the negative. K is this number, 0.099287 times 10. And just plug that in your calculator to figure out what it is. All right, hopefully that helps you with those questions. They're good ones.